Let's explore number systems beyond our familiar decimal system. We will be looking at octal, which is base 8, and hexadecimal, which is base 16. These systems are essential for efficient data representation in computers. The octal system, or base 8, uses 8 digits ranging from 0 to 7. Each position in an octal number represents a power of 8. For example, we have 8 squared, 8 to the power of 1, and 8 to the power of 0. Here's how counting works in octal. In decimal, we count 0, 1 all the way up to 7. In octal, these are the same. However, the decimal number 8 becomes 10 in octal. 15 becomes 17, 16 becomes 20, and 64 becomes 100. Let us see an example. The octal number 157 base 8 can be converted to decimal as follows: 1 times 8 squared, plus 5 times 8 to the power of 1, plus 7 times 8 to the power of 0, which equals 64 plus 40 plus 7, resulting in 111 in decimal. To convert an octal number to decimal, we can follow these steps. First, identify each digit in the octal number. Second, multiply each digit by its corresponding power of 8, based on its position. Third, sum all the products obtained in the previous step to get the decimal equivalent. Let's take 2, 4, 5 base 8 as an example. The positions are 2, 1, and 0. So we have 2 times 8 squared plus 4 times 8 to the power of 1 plus 5 times 8 to the power of 0, which equals 2 times 64 plus 4 times 8 plus 5 times 1, which equals 128 plus 32 plus 5, resulting in 165 in decimal. To convert a decimal number to octal, use the division method. First, divide the decimal number by 8. Second, record the remainder. Third, repeat this process until the quotient is 0. Finally, read the remainders from bottom to top to get the octal number. For example, let's convert 83 base 10 to octal. 83 divided by 8 equals 10 with a remainder of 3. 10 divided by 8 equals 1 with a remainder of 2. 1 divided by 8 equals 0 with a remainder of 1. Reading the remainders upward, we get 123 base 8. We can verify this by calculating 1 times 64, plus 2 times 8, plus 3 times 1, which equals 83 in decimal. The hexadecimal system, or base 16, uses 16 symbols, the digits from 0 to 9, and the letters A, B, C, D, and F. The letters represent the numbers 10 through 15, respectively. Each position in a hexadecimal number represents a power of 16. For example, we have 16 squared, 16 to the power of 1, and 16 to the power of 0. Here's the counting sequence in hexadecimal. 9 in decimal is also 9 in hexadecimal. 10 becomes A, 15 becomes F, 16 becomes 10, 31 becomes 1F, 255 becomes FF, and 256 becomes 100. As an example, consider the hexadecimal number 2A5 base 16. This is equal to 2 times 16 squared, plus a times 16 to the power of 1, plus 5 times 16 to the power of 0, which is 2 times 256, plus 10 times 16, plus 5 times 1, which equals 512, plus 160 plus 5, which equals 677 in decimal. To convert from hexadecimal to decimal, we can follow these steps. First, convert any letters in the hexadecimal number to their corresponding decimal values. Second, multiply each digit by the appropriate power of 16. Third, sum all the products to get the decimal equivalent. For the example 3b7 base 16 with positions 2, 1, and 0, we have 3 times 16 squared, plus b times 16 to the power of 1, plus 7 times 16 to the power of 0, which equals 3 times 256, plus 11 times 16, plus 7 times 1, resulting in 768 plus 176 plus 7, which equals 951 in decimal. To convert a decimal number to hexadecimal, we use the division method. First, divide the decimal number by 16. Second, Convert the remainder to its hexadecimal equivalent. Third, repeat the process until the quotient is 0. Fourth, read the remainders upwards to get the hexadecimal number. Let us consider 2748 base 10. When divided by 16, it gives 171 with a remainder of 12, which is equivalent to C in hexadecimal. 171 divided by 16 equals 10 with a remainder of 11, which is equivalent to B in hexadecimal. 10 divided by 16 equals 0 with a remainder of 10, which is A in hexadecimal. Reading upward, we get a BC base 16. We can verify this as follows: A times 256 plus B times 16 plus C times 1 equals 10 times 256 plus 11 times 16 plus 12 times 1, which equals 2748 in decimal. Octal is often used for representing Unix permissions and in assembly language, as well as in digital electronics. For example, the command chmod755 file name sets permissions such as read, write, and execute for the owner, group, and others. Hexadecimal is used for memory addresses, color codes on the web, and representing machine code. An example of a color code is #FF5733 for orange, and a memory address could be 0x2A4F. Here is a summary comparing decimal, octal, and hexadecimal. Decimal has a base of 10, using digits 0 through 9. Octal has a base of 8, using digits 0 through 7. Hexadecimal has a base of 16, using digits 0 through 9 and letters A through F. The decimal number 255 is 377 in octal, and FF in hexadecimal. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.